Okay, welcome to another video on math, and today we will be looking at a new concept known as radians. And yes, we're not looking at circle problems anymore. Well, even though radians are kind of related, they're sort of. They're somewhat related to radians, but related to circles. Actually, yeah, they're basically just circles. So, to begin, we're gonna define what a radian is. So, first thing we do, let's say we draw a circle. Ah, yes, a circle. Nice. Now we have our we have a center O. Okay, and then we're gonna draw a distance from O to a point on the circle, and that, everyone, we all know, is the radius, denoted by R. Now, before we talk about radians, let's quickly recap what a degree is. So, in the beginning, you were introduced something called angles. Okay, what are angles? Well, you have basically, you have two lines joined together, but then there are some distance apart under the condition that one of their points, they meet at one point. So, and then this has some angle theta, and this is known as the degree. And in fact, we can translate this onto a circle. So we're not going to use a circle, so we have our circle. I want to draw another circle, and then by convention, we define this line that is parallel to the x-axis. Okay, so we're just gonna put our circle on the coordinate system, I guess. And by definition, we define this point as 0 degrees. And then we define angles counterclockwise. So for an angle like this, okay, this is a pretty easy one. This is our classic 90 degrees, right? This is 90 degrees. And then, well, how many degrees is in a circle? Well, we can see it's basically just 4 times 90 degrees, which we all know is 360. So from a circle standpoint, it looks like 0 degrees and 360 degrees are essentially the same place. Well, yes, and this will come in handy when we are dealing with trig functions and trigonometric equations, but we won't get into that today. So we know what a degree is. Okay, so how do we know that in a full circle there's 360 degrees, huh? Well, you might think, okay, radians, yeah, that there must be a connection, right? Well, not really. We kind of just defined what 360 means in a circle, and we use that in our daily lives. So now we can get into radians. So yes, so what is a radian? Well, yes. So yes. So okay, where were we? Okay, yes. We started talking about radians. So instead of defining 360 degrees as a full turn, we can you need to do is use the fundamental properties of a circle. So what do I mean by that? Well, let's say, okay, we're going to use our circle. We draw a second point. Okay, we're going to call this A, and then the second point B. And then the distance from A to B. Okay. The distance from A to B. This is known as an arc length. This is known as an arc. Okay, probably I can't really see that, but it's all right. And the arc length of this arc, the length of this arc. So, okay, if the length of this arc is equal to the radius, the length of the radius, then the angle we define here, this angle, this theta right here is equal to 1 radian. Okay, so this is a much more natural way to define an angle. We just base it on the radius, right? So now the question is, if there are 360 degrees in a circle, how many radians are in the full circle? Well, if we look back to the formula for circumference, okay, we're just gonna note that down. So note circumference is equal to 2 pi r. Well, let's see, right? We know that in a full circle, we know that the circumference of a circle is 2 pi r. Therefore, it's the total length of the circle. And so it's our radian times some amount, and that amount is 2 pi. So therefore, full circle equals 2 pi radians. Okay, this is essentially what we need for radians. Now, so the question is, how can we convert between the two? Well, we can set it up as a ratio. So we have a ratio. Which is 360 over 2 pi, which is 180 degrees over pi. And now you may notice half a circle, or half a turn around a circle is, so this, okay, we'll draw another circle. So 180 degrees is equal to pi radians. And that essentially forms the basis of converting between angles and degrees and radians. So if we have something like 90, well, we can just simply multiply by our ratio here. And we find that that is equal to pi over 2. And likewise, 60 degrees. What's 6 degrees times pi over 180? Well, that's just going to be pi over 3. And in general, we would write radians in terms of pi. But they're on it's rare to see radians written as just a number. And so, okay, in fact, if you really want to know, 1 radian is approximately 57.30 degrees. Well, where does that come from? Well, we have to remember that the ratio is 180 over pi, which is actually 57.3 degrees. And that's about it.